In this video, we're going to solve some definite integrals using the substitution method. But first, let's look at some theory. If g prime of x is continuous on a closed interval ab, and f of x is continuous on a range of u is equal to g of x, then the integral from a to b, f of g of x times g prime of x dx is equal to integral from g of a to g of b, f of u du. Notice the transformed limits, g of a and g of b, and that comes from the substitution method, letting u be equal to g of x. So let's do an informal proof. Let u be equal to g of x, that's the inside function, du is equal to g prime of x dx. Now x equals a, plug that into u is equal to g of x. We transform the limits so they become u limits, so we get u is equal to g of a. X equals b, that's the upper limit for x, and plug that into u is equal to g of x, and the upper limit for u becomes u is equal to g of b. Alright, so what we have is integral a to b, f of g of x times g prime of x dx. The u is equal to g of x, du dx. The derivative, that's equal to g prime of x. Multiply both sides by dx, and we get du is equal to g prime of x dx. And we also transform the limits, so x equals a, transform that limit, and we get u is equal to g of a. These are the u limits, g of a. X equals b, transform the limit, and we get u is equal to g of b. So what we have is integral from a to b, f of g of x times g prime of x dx. Now f of g of x, this part is f of u, because we substitute u equals g of x, g prime of x dx, and this part is du. Alright, so what we have is integral from a to b, f of g of x times g prime of x dx. We transform the limits, so we now have u is equal to g of a, and the upper limit is u is equal to g of b. The integrand is f of u du. Alright, so what we have is antiderivative of f of u, that's going to be capital F of u. We're going to apply the fundamental theorem of calculus. U is equal to g of a, that's the lower limit. U is equal to g of b, that's the upper limit. Substituting the upper limit in, we get f of g of b, and substituting the lower limit, we get f of g of a. So what we have shown is that the integral from a to b, f of g of x times g prime of x dx, that's equal to capital F of g of b minus capital F of g of a. Alright, let's look at some examples. Here we have integral from 0 to 1, x e to the x squared, sine of e to the x squared dx. We start by making a substitution. Let u equals the inside function inside the sine function, u equals e to the x squared. The differential du is equal to, apply the chain rule, we get e to the x squared. Differentiate the exponent, and that's 2x dx. Alright, let's change the limits. X equals 0, that's the lower limit. U is equal to e to the x squared. So we get u is equal to e to the 0, and e to the 0 is just 1. X equals 1, that's the upper limit for x. Plug that into u, we get u is equal to e to the x squared. So u is equal to e to the 1, and that's just e. Alright, so what we have is integral from 0 to 1, e to the x squared, sine of e to the x squared, times x dx. Now, this part is going to be, this part of the integrand is going to be sine of u. And e to the x squared, x dx, that's going to be, well, if we divide by 2 both sides, we're going to get 1/2 du is equal to x e to the x squared dx. So this part is just 1/2 du. So we transform the limits. The u limits are now from 1 to e, and we get sine u times 1/2 du. 1/2 is a constant. It passes through the integral. So we get 1/2 integral from 1 to e sine u du. What is the antiderivative of sine u? That's just going to be negative cos u, so that's negative 1/2 times cosine u, evaluated from 1 to e. Now apply the fundamental theorem of calculus, and we get negative 1/2 times, putting the upper limit in, we get cosine e, minus, put the lower limit in, we get cosine 1. This is the answer. All right, let's look at another example. Here we have integral from 1 to e log x cubed divided by x dx. We will make the substitution. U is equal to log x, that's the inside function, and du, the differential du, is equal to 1 over x dx. Let's put this in a box. Now let's change the limits. X equals 1 and u is equal to log x. This is the variable of substitution. So we get u is equal to log 1, and log of 1 is 0. X equals e, plug that into u is equal to log x, u is equal to log e, and log of e is just 1. So what we have is integral from 1 to e log x cubed. Let's rewrite this in a way that makes it easier to see the substitution, times 1 over x dx. Now this part is going to be u cubed. And this part, 1 over x dx, that's just du. So this is equal to integral from 0 to 1, transforming the limit, u cubed times du. Reversing the power rule, antiderivative of u cubed is just going to be u to the 4, divide by 4, apply the fundamental theorem of calculus from 0 to 1. So we have u to the 4th over 4, evaluated from 0 to 1, put the upper limit in, we get 1/4, minus, put a lower limit, because 0, the answer is 1/4. So we have shown that the integral from 1 to e log x cubed divided by x, integrated with respect to x, the value of this definite integral is 1/4, and we did that by using the substitution method. All right, let's look at another question. This is a theory question. What we're given is integral from 1 to 9, f of x dx is equal to 10. Our goal is to find the integral from 0 to 2, f of x squared, f of x cubed plus 1 dx. We're going to start with the question, which is finding the integral from 0 to 2, x squared, f of x cubed plus 1 dx. So we do the substitution, that u be the inside function, u equals x cubed plus 1. Du, the differential, will be 3x squared dx. Let's divide by 3 both sides, and we get 1/3 du is equal to x squared dx. So let's rewrite this integral, because 0 to 2, f of x cubed plus 1 times x squared, and integrate with respect to x. Now, this part of the integral is just going to be f of u. And x squared dx, we showed here that is going to be 1/3 du. The limits have been transformed. Actually, let's transform them. So we have x equals 0. Plug that into u is equal to x cubed plus 1. Plugging x into u, so we're going to get u is equal to 0 cubed plus 1 is 1, and x is equal to 2, that's the upper limit. Plug that into the expression for u equals x cubed plus 1, and we get u is equal to 2 cubed is 8 plus 1, that's 9. So we transform the limits, we now have u limits, u is equal to 1, and u is equal to 9. Before we had x limits, x equals 0, and x equals 2. All right, so we have f of u times 1/3 du. Now 1/3 is just a constant, it's going to pass through the integral. So we get 1/3 integral from 1 to 9, f of u du. Now, how do we find this integral? Well, we're actually given the answer to this question in the question itself. The integral from 1 to 9, f of x dx is equal to 10. So this is just 10. U and x are just dummy variables, so we now have the answer as 10 over 3. This is the answer. All right, thanks.